Selective discharge of ions. Now the ions, some of the ions move toward cathode and some move toward anode. Suppose two type of positive ions move toward cathode. Then which ion will discharge at cathode? This depends on three factors. Number one is relative position of the cation or anion. Relative position of the cation or anion in the reactivity series. The ion which has the lower position in this series, that will discharge first. Suppose two type of ions, copper ion and hydrogen ion, they reaches cathode. So you see the position of copper and hydrogen. Hydrogen and copper, which has lower position? Copper has lower position than hydrogen. So copper ion will discharge at cathode. Now in the same way, suppose if chloride ions and hydroxide ion reaches anode, then hydroxide ions will discharge at anode because they have lower position than chloride ion. So remember, the ion which has lower position will discharge at the respective electrode. Second is concentration of the ion. The ion which has more concentration has more chances of discharging at the electrode. And third is the nature of the electrode. Nature of the electrode, if the electrode is neutral, then following 2 points, these 2 points will be followed. If the electrode is active, then suppose two ions move towards cathode, but none of them will be discharged there because the electrode is active. Active electrodes themselves loses electron and forms ion. None of the ions are discharged at active electrodes. They loses electrons themselves and forms ion. Let us see one example to make it more clear. This is the example shown for the electrolysis of lead bromide solution. So in lead bromide solution, when electricity is passed, then lead bromide dissociates into lead ions and bromide ions. Now this is positively charged ion, that's why it will move towards cathode. Now cathode is a reducing electrode, that's why it will receive, here the reduction will take place. This lead ion will take 2 electrons from the cathode and convert into neutral lead atom. So at cathode, lead metal, that is of silver grey color, will get deposit. Now at anode, negative ion will move, that is the bromide ion. Now this is the oxidizing electrode. So this bromide ion will lose 1 electron to form bromine atom. Now these two bromine atoms will combine to form bromine gas. So at anode, the bromine gas will be released, that is reddish brown in color. Now remember one thing, always the metals get deposit at cathode because metals form positive ion, that's why they are always deposited at cathode. So here we have used inert electrodes that do not participate in the process of electrolysis. Let us see one more example. This is the example of electrolysis of water. In electrolysis of water, when electricity is passed through water, then it dissociates into hydrogen ion and hydroxide ion. Now remember that pure water is a non-electrolyte. Pure water is non-electrolyte. So in order to make it electrolyte, we add a little acid. We can take sulfuric acid in it. So water will dissociate to form hydrogen ion and hydroxide ions, and sulfuric acid will dissociate to form hydrogen ions and sulfate ions. So you can see here, hydrogen ions are positively charged ion. They will move towards cathode. At cathode, reduction will take place and it will convert into hydrogen atom. 2 hydrogen atoms will combine to form hydrogen molecule. It means hydrogen gas will be produced at cathode. At anode, these two ions will move, sulfate ion and hydroxide ion, because both are negatively charged. Now these two ions will move towards anode, but only hydroxide ion will discharge because it has lower position in the reactivity series in comparison to sulfate ion. So only this hydroxide ion will discharge here. It will lose one electron to form OH, and 4 OH will combine to form 2 molecules of water and 1 molecule of oxygen gas. It means oxygen gas will be released here. Now you can see here at the electrode, inverted test tubes are kept to collect the gases. So this can be asked that which gas is formed at cathode. So at cathode oxygen will form, at anode hydrogen will form. When you check the volumes of these two gases, then you will see that hydrogen and oxygen they are formed in the ratio of 2:1.